Basic Calculus, Optimization Part 3. Bit of a reminder once again, because we're now going on to examples for you to do, and they're all examples involving more than one variable. So if you're finding, for example, a maximum volume, area, cost, you'd find an expression for that volume, area, cost. You must make sure that it only has one variable, so you need to use, if it has two variables, you need to use some other relationship between the variables to solve for the one in terms of the other and substitute. Maximum minimum occurs when derivative equals 0. So you need to differentiate equal to 0, solve for x, or the variable. Then you need to go back and substitute into the second derivative to show that it is the maximum or minimum. And then you substitute into your expression which you found in order to find the actual maximum, volume, area, cost, whatever. Notice that the number 4 is often not asked for. So it does depend on what is asked for there. So let's go into the first example. Now there are something like 7 examples. So instead of putting them all at once, each is done and then the answers handled thereafter. So here's the first one for you to try. So in each case, once you get to an exercise, pause and try the exercise yourself, and then the answer follows immediately. In this first case, rectangular box without a lid has a length of 2x plus 4, breadth of x plus 2, 2x plus 4, x plus 2, h. It has 5 surfaces. There's no lid, but there's a base, so that's 1. There are 2 sides, the same, exactly the same, and a back and a front exactly the same. So, if the total surface area of the box is that, show that the height is that. Well, in other words, we need to form an equation in order to find the height. By the way, here's the answer. We can find the surface area in terms of x and h, and there we know it in terms of just x. So find in terms of x and h, and then equate to that and solve for h. So the surface area in terms of x and h, the base, 2x plus 4 times x plus 2, plus the sides. So it's h times x plus 2 doubled. The front and back, well, it's h times 2x plus 4 doubled. Yeah. And we're told it's equal to 80 plus 32x minus 4x squared, so there we are. And we can solve that for h. At this stage, I'd rather take out a common factor of h, subtract that on this side, common factor of h, and divide. Now that needs to simplify down to 6 minus x, so we need to factorize. Well, there's a common 6 that comes out, and that quadratic can factorize. Hopefully it must have an x plus 2, so that cancels, and hopefully it must have a 6 minus x, so that appears. Well, it does. And therefore we've now shown number 1. Number 2, hence determine the volume of the box in terms of x. Using this. That's what hence means, using what you've just shown. And if you had trouble with this in exam, it does mean you're not allowed to do this. If that's worth 4 marks, then that's worth 6 marks. You might lose your 4 marks there if you can't do it, but you can still do this using that fact and get your full 6 marks. Volume of the box in terms of x. So that's just a case of length times breadth times height. Eh? Length times breadth times height. 2x plus 4 times x plus 2 times the height, which we've shown is 6 minus x. Multiply it out, and there is our volume. Calculate the value of x if the volume is to be a maximum. So we're going to differentiate the volume, because volume maximum means derivative of volume equals 0. So there's derivative equal to 0, and we're going to solve that for x. Factorize 2 possible values. Often we automatically reject the negative answer when we're talking length, but be careful because this is 2x plus 4x plus 2. So we need to make sure this won't give a negative. Otherwise, we'll have to check it with second derivative, but it will give a negative, so we can deject that answer. So 2 is the only possibility. But we'll have to check. So let's find the second derivative. Differentiate that. There it is there. For maximum volume, we need 2 to make this negative. Well, if I substituted 2 into there, I would get a negative. We don't need to know the value of the second derivative, just that it's positive or negative. And it will be negative for x equals 2. Therefore, a maximum for x equals 2 centimeters. And that's it, because we're only asked for the value of x for the volume to be a maximum. Next question. Similar to one we've had before. Try this yourself. Right, express height in terms of r and theta. Well, that means I need an expression involving h, r, theta without any other variables. It can only come from the volume. So there we are. There's volume equals pi squared h. So therefore pi squared h must equal the 2000. And we can solve that for h. So there we are. H is equal to 2000 over pi squared. Show that the surface area is given by that. Well, in other words, find the surface area. By the way, here's the answer. So there's the surface area. And we can substitute that value of h for in there because we cannot have two variables. And it simplifies down to what we need. And in a nice, useful, differentiable form. Number 3. Cylinder must be minimum. Therefore, I need to differentiate equal to 0 for the area. Area minimum means derivative of area 0. And we're going to solve that for r. 4's cancel. If 4 cancels, we'll end up with 1000 over pi r cubed. So therefore, we need to cube root. And there is our answer. Strictly speaking, we should be finding the second derivative. I don't think I've done so. But second derivative would be 4 pi plus 8000 r cubed. And it's very easy to show that that is positive for r being positive. Here's a question involving a graph. OPQR is a rectangle. And we need to work with the volume, that area of that rectangle. Right. Let's do it. We have to find the equation of this line in order to find the y value. That's pretty straightforward. Y-intercept, x-intercept, we leave that to you. Y equals minus 2x plus 6. Now, in order to find an expression for QR in terms of k, we need to know the y value of q, because then that will be the length of QR. So, we say there's the equation. What's the x value of q? Substitute in there to get the y value. Well, xq equals k. All of these are k because the distance is k, therefore yq equals minus 2k plus 6, substituting k. Find the coordinates of q for the rectangle to have maximum area. Well, that means we must find the area, length times breadth. K minus 2k plus 6. Multiply them together. And we need to differentiate equal to 0 to find maximum area. Solving that, we get k equal to 1.5. So now we need to determine that maximum. So we just substitute 1.5, we're still determining the coordinates. We substitute 1.5 in to there, and 1.5 into there for the coordinates of Q. There they are there. Determine the maximum, substitute into our formula, and we get a maximum of 4.5. Next question. Bag, airline bag. The length, breadth and height must equal 115. Fussy airline this, with the length being 55. Show the volume can be represented by that. Well, you'll notice the volume in terms of x. So therefore we have to find the volume, which is length times breadth times height. Volume, length times breadth times height, which is 55 times x times h. Now we have a problem there because there are two variables. But the fact that length, breadth and height add to give 115 with length 55 allows us to form an equation with x and h. Length plus breadth plus height equals 115, so that means 55, x, h add up to 115. Solving that, we get h equal to 60 minus x, and we can boom that in for h there. Here we are. So we have volume equal to 3300x minus 55x squared. Now we need to find the maximum volume of the bag, so what we need to do is differentiate equal to 0. Solve for x, so we get x equal to 30. Maximum, minimum. Let's check second derivative, negative 110. Well, that's always maximum because it is a concave down negative second derivative. Therefore, maximum. We need to find the maximum volume of the bag. So there's the value of x for the maximum volume. We need to substitute into our formula to get the maximum volume. And there we have the maximum volume of the bag. Next question. Looks pretty complicated, but picture the satellite is shaped like a capsule, like a flu capsule. Bit of explanation. That's a hemisphere on the end, which is half a ball. Hemisphere on that end. So together they make one sphere. The area of a curved surface area of a sphere is 4 pi squared. So therefore we have a 2 pi squared there and a 2 pi squared there, but together it gives us our 4 pi squared. Notice if you have a hemisphere on its own and you're talking about its surface area, that's different. But then that's not curved surface area because it'll be an extra pi squared. So the full surface area, just for interest's sake, of a hemisphere is 3 pi squared. 2 pi squared for the curved and 1 pi squared for the flat. That's just side issue. Cylinder, 2 pi h. It's only the lateral area we're considering. In Optimisation 2, we talked about the full surface area of a cylinder, but this is just the lateral. We're not looking at circles at the end. So try it yourself first. We need to show that h equals that. Well, we need a relationship between h, r, and a number alone in order to do that. Well, we know the volume of the satellite has to be pi by 6. And the volume of the satellite is hemisphere plus cylinder. Well, which means that it's going to be half of that plus half of that again plus the cylinder. So it's going to be that plus that. So there we are, volume equals. And I'm putting it equal to pi by 6 because that's what we told the volume has to be. Now we can solve that for h. There we are. And there's our value of h. Hence show that the outer surface area of the satellite can be that. Well, in other words, it says using this, hence means using this, show this. And show this means find the surface area, by the way, here's the answer. Remember, if you can't do that, if you have trouble doing that, you can still use it here. If you have trouble doing that, we can still use it here and still get the marks in an exam. So now we have to show the total surface area is given by that. Well, it's going to be hemisphere curved plus cylinder curved, which means it's going to be sphere curved plus cylinder curved. Sphere and cylinder. There we are. So therefore we know the area is going to be sphere and cylinder. Now we need to get rid of, notice this has no h, so we need to get rid of the h. We know h is that. So we've substituted, we simplify, and that's exactly what we want there. I've got a step further to make it differentiable. Now we have to calculate minimum outer surface area, so it means we need to find surface area and differentiate equal to 0. Solving, r cubed equals 8, r is a half. Haven't finished yet, of course, because now we have r as a half. We have to find the actual minimum outer surface area. First of all, we're going to find the second derivative to confirm that it is going to be a minimum. Differentiate that. There it is there. And if we put a positive value, that's always positive, it's constant. This is positive for a positive variable, so therefore we know it's got to be positive for r equal to half, and therefore a minimum. So now we have to find the actual minimum area. Well, we know the area is that, so we're going to substitute it in, and we get pi as our area. Minimum area. Next question. Here we have another case of the wire being cut in two pieces with a square and a circle. We had one in Optimisation 2. So now first of all it says if the length of the wire used to make the circle is x meters, write in terms of x the length of the sides of the square in meters. Don't forget that out. Right, try it yourself. Okay, there we are. How did we get that? Well, if x is used for the circle, then 4 minus x is left for the square, and it has 4 sides, so 4 minus x over 4. So the sum of the areas of the circle and the square is given by that. Now notice that there's no L for the length of the square, there's no R for the radius of the circle, it's all in terms of x. So we need to do that first. So, there's our circle, pi squared, 2 pi r for the area, circumference. There's L squared or 4L for the area and perimeter. Now we need sum of the areas, so the sum of the areas is going to be pi squared plus L squared. Now r we need in terms of x. Well, we're going to do that. The circumference, 2 pi r, is equal to x. So therefore r is x over 2 pi. So we now know we can put x over 2 pi instead of r. L we already know. We found it before. It's 4 minus x over 4. So therefore we can now substitute into our formula. There we are. Simplifying, we end up with that there. And we get to talk about minimum area. So we're going to differentiate and put equal to 0. Solving for x. There we are, 1,76. Now we need to confirm that that is a minimum. Second derivative, there it is there. Well, look, it's always positive, both constants, the second derivative. Therefore, minimum. So, therefore we know that the circle should be 1,76 meters. And the square is 4 minus that, 2,24 meters used for the square. Rectangular box is constructed in such a way that the length of the base is 3 times as long as its width. So therefore L equals 3x if you like. The material used to construct the top and bottom of the box costs 100 Rand per square meter, while the material used to construct the sides costs 50 per square meter. Rand, dollars, yen, whatever. The box must have a volume of 9 meter cubed. Let the width be x. Determine the expression for the height x in terms of x. The height in terms of x. So the volume has to be 9. Right, try this yourself first. Right, let's have a look at it. The volume must be 9, which means length times breadth times height must be 9. Yeah, length times breadth times height must be 9. Now the length is 3 times the breadth. So therefore 3x for L. There's the breadth, there's the width, x, and there's the h. And we know that it is equal to 9. So that allows us to find h. h is equal to 3 over x squared. So there's the first one. So the cost to construct the box can be written as that. Well, remember it's 100 times the number of square meters of the top and bottom plus 50 times the number of square meters of the sides. So cost equals 50 times, and the sides is going to be L times H plus X times H twice, because there are 2 of them. There's 2 there, 2 that side, 2 here, 2 that side, 2, 1 here, 1 that side, making 2, 1 here, 1 that side, making 2. And then there's going to be 1 here, 1 top there at 100. 2LX. There it is there. And we need to get rid of the H. And the L. Well, the L we know is 3x, that's easy. And the H we know is easy as 3 over x squared. So there we substituted in all the values. There we are. And we found it as they told us to. Remember once again when they say show the cost as that, that means find the cost. By the way, here's the answer. If you can't find that, if you have trouble, you can still go on to do the next part and get your marks. A bit repetitive. I keep saying the same things, but I want to drum it in. Now we have to calculate the width of the box if the cost is to be a minimum. So we're going to find the minimum, the value of x for that to be a minimum, that to be a minimum. So we're going to differentiate, put equal to 0, and solve for x. Oh, x is 1. And we need to confirm that it's going to be a minimum, so we differentiate the derivative. There we are. And we get the second derivative. And for x1, this is always going to be positive, and therefore a minimum. And therefore we have confirmed that the width of the box, x must be 1.